The classic rate in versus rate out sort of a situation where you've got a rate that's causing the water tank to fill up, another rate that's causing the water tank to empty, R of t and W of t. Let's just remind ourselves a little bit about what we did yesterday. If I remember correctly, with A, we said that the net rate was W of t minus R of t. And did we say that that equaled like A prime?
Yes.
Okay, so we said something like that. Then we used that A prime of t to decide whether the water, the amount of water was increasing or not. And then in part B, what was the big technique that we used in B to help us answer that question? We did an integral, yeah, definite integral. So we said the integral from 0 to 18 of W of t minus R of t dt. That was part of it. And let's remember this from yesterday. Do you guys remember what that stood for? Like if you had to explain with a sentence or two, like what that meant, what would you say? It's the amount of change of water in the tank, right? It's the definite integral of a rate. And so that right there, that by itself was not how many gallons of water were in the tank. What did we have to combine that with in order to get the final amount? The initial amount, which in this case was 1,200. So if we just put 1,200 right here, we added that to the change, didn't it end up being like 1,310? Okay, so 1,310 gallons for the amount at t equals 18. So that's what we did yesterday. Moving on to C. C says, at what time t on the closed interval 0 to 18 is the amount of water in the tank at an absolute, that feels like a pretty key word, absolute minimum. Show the work that leads to your conclusion. What do you think? What does that keyword tell you? Absolute minimum. Tell me what you think of when you hear that. Endpoints and critical numbers, right? Okay, so the candidates are set for us. Endpoints, critical numbers, critical points, whatever you want to call them. That's what we're looking at. Okay, so the endpoints are really obvious, 0 and 18. How are we going to find the critical numbers for this net rate? A prime equal to 0. Exactly right. So you could also say W of t minus R of t, which is of course the same thing, equal to 0. But that's what you want to do. You want to set your net rate equal to 0. This will allow you to find those critical numbers. That equation, is it important that that equation is written down, or is that sort of an unnecessary detail? It's a very necessary detail. What about all the details on getting from that to your answers? Like to your critical numbers. You got to show all the little details in between. How are you going to get there? Calculator, right? So I definitely am interested in seeing net rate equals 0. Let me just put it like this. I really don't want to see you trying to do all the detailed steps in between, because that's just going to waste your time. I want you to jump straight to the calculator, use either the intersection finder or the zero finder, depending on how you set it up, and solve the equation via calculator. Let's hear what you get once you get it. So McKenna, you said, did you agree with the 6 point whatever it was? So t equals 6.495. Did I hear that right?
Yeah.
Okay, and what was your other one?
12.975.
Okay, so let's see if we can get some consensus on this. Are those the critical numbers you guys got from finding zeros and intersection points? Definitely an important skill. I would say finding zeros using the calculator is something that, as far as the AP test is concerned, is definitely an important thing for me as well, right? Being able to solve an equation like that. It's just simply not going to happen without the calculator. And so you want to be able to use the calculator effectively and get those. So are we all confident that that's it? Okay, so you guys said endpoints and critical numbers are the candidates. And so of course the endpoints are right there, 0 and 18. Critical numbers we just found. What do we typically do with those? We make a table, right? Yeah, there we go. We make a table, and so I'm just going to say my inputs are going to be t's, and they're going to be 0, 6.495, 12.975, and 18. What should my outputs be? That right-hand column. What do you think? Like what category? What do we want to find? A, what does A stand for? Whoever said that? Yeah, amount of water. Yeah, amount of water. Did we set that up before? Did we set that up yesterday? That A of T stood for the amount of water? Okay, so I'm going to write A of T. Don't you have a choice here? Couldn't you be plugging back things into A prime? And that would be wrong, right? We're not looking for where the rate is biggest or smallest. We're looking for where the amount is at a minimum. So, yeah.
If we were looking at a graph, couldn't we get rid of 12.9 because we know it goes from positive to negative?
Sorry, I forgot the 7 on that one. You know what? I think that's a wise move. We'll talk about that in a second. Because you got the graph right in front of you, right?
Yeah.
Okay. I just want to make sure we're clear on what we would be considering plugging in and evaluating, right? So you get your endpoints, you got your critical numbers, and let's talk about that now. So Jonathan said one of those critical numbers we could just immediately discount. And explain again why you would say that's not the min.
Because A prime goes from positive to negative, which means that A will be a relative maximum and not minimum.
Which can't be the absolute minimum, right?
Yeah.
If you have a relatively high point, there's no way that that could be the lowest, right? So I think we could dismiss it right away. You could just do this. You could say 12.975 is a relative max. And so you just basically dismiss it.
Okay.
Yeah, that's fine. But I do want you to consider all the candidates. And I would say what we just did right there, we just considered it, right? We said, it's relative max, so that's not it. We don't have to bother with it beyond that. Okay. Doing okay? Has this seemed pretty similar to what we did in the past so far? It's about to be a little different. Here's why. We need to fill in the outputs for A of T, and we actually already know one of them. One of them has already been done for us. It's going to, once we recognize it, it'll take it like 3 seconds to fill it in, if that. Which one do we already know about?
0.
Yeah, when T is 0, A is 1200. So what it's going to come down to now is how do we handle the other two candidates, 6.495 and 18? Because normally, didn't we take the 6.495 and plug it into the A of T function? Anybody want to point out where the A of T function is? Well, other than that, it's nowhere, is it? What do we have, though?
Math 9.
We have A prime, and we'll use Math 9 with it. Yeah, Math 9 might be the key thing, right? But to be able to set things up to be actually to use Math 9, we need to consider the integral and A prime and how that works together. So if I want to know how much water is in the tank at 6.495, anybody have an idea on how we could set this up? Go ahead, Jonathan.
Take the integral of the WT minus RT from 0 to 6.495.
Okay, 0 to 6.495, okay?
And then evaluate the function from 0 to...
So actually do Math 9 with that.
Yeah.
Okay, why don't you guys do Math 9 with that? Let's see what it ends up being. And by the way, don't you have W of T minus R of T already in your Y1? This is a key to save you huge time. You already have it in your Y1. Can't you just use the vars, Y vars, Y1 within your Math 9? That would make life so much easier for you instead of trying to re-enter the whole W of T minus R of T thing. Push the vars button when you come to your integrand. Vars, Y vars. Yeah, sorry. Vars, Y vars, and then just select whatever
You got a function.
function you put in there.
674. Is it the absolute value because it's a minimum?
No absolute values anywhere. What'd you guys get?
Negative 674.757.
674.758. Correct? Negative 674.758. So how many of you are bothered by that answer? Why are you so bothered?
I got a positive.
Oh, you got a positive.
That's why I'm bothered.
Did you get positive 674.7?
I don't know how.
Let me ask you this. Did you flip the W and the R around? Positivity or negativity. Does that answer bother anybody?
Yeah.
What are we trying to find?
The
Amount of water. So does that answer bother you? Why?
Because it's
Because it's negative. Can you have like negative 600 gallons of water? No, you can't have negative 600 gallons of water. So what we've done here is we've calculated something that is definitely useful, but we have misinterpreted its meaning. That is the amount of change. How much water was in there to begin with?
1,200.
And so how much water, how could we figure out the amount of water at 6.495? Add 1,200 to that. So if you go 1,200 plus that, now we end up with an answer that does make sense. It'll be a positive number. So negative 674.758 plus 1,200. It's going to be 525 point something. Is that right?
Yeah.
525.242. Okay. Gallons, yeah. Okay, so is that a candidate for the min?
Yeah.
Definitely, because it's less than 1,200, and we know the other candidate was a relative max. The only other option that could dethrone what we just found as the min is what happens at 18.
13.
What's that?
It's 13.
Haven't we already figured this out?
Yeah.
Yeah, we figured this out back in B, right? And so in B, we use the same process, and it's 1310. Can use that answer there. And so now we can actually draw a final conclusion. We want to call out the answer. We want to say the min is 525.242 gallons. It did ask for what time, so I guess we could say at t equals 6.495. So as far as showing the work that leads to your conclusion, it's your table. It's considering all the candidates, and then the little bit of work you had to do to fill out your table. That would be the work leading you to your conclusion.
Would you have to justify your answer at all?
No, that's kind of what I was getting at. Like the work really is the justification. Because when you say justification, that's when we tend to think of, hey, A prime went from negative to positive, or positive to negative, or whatever. With absolute extrema, we are not really concerned with that, other than maybe dismissing the relative max, right? We're concerned about what is the highest output, what is the lowest output. And so really it's our table that considers all the candidates. That's your justification, right? That's your reasoning. So, okay. Any other questions? You guys did really well with that. You did really, really well. Way to find the other clues within the question about where to put what within the table, but you did very well. Okay, let's go ahead and take a look at D. I'm glad you did well because D is going to cause you to think just a little bit. Let's check it out. I'll read it out loud here. It says, for time greater than 18. So now we're beyond that initial domain. Time has moved past 18. No water is pumped into the tank. So that means that W of T stopped, right? W of T is no more. So no more water is pumped into the tank. But water continues to be removed at the rate R of T until the tank becomes empty. So if you shut off the W and R continues, then eventually the tank will empty, right? Okay. Let K be the time at which the tank becomes empty. Write, but don't try to solve an equation that involves an integral that you could use to find that time K when the tank is empty. I'm hoping this will cause you to think a little bit. But based on how you're doing, I'm guessing that many of you will probably figure out something really good. So give it a shot. Talk it over. Check in with you in a second. Any volunteers want to throw an answer out there? Titus, your hand is up first.
I'm not sure if this is right, because I'm not sure how we would find K from it all that much.
Okay.
But I got 1310 minus the integral from 18 to K of R of T dt equals 0. But I'm not sure how.
Titus, we disagree.
So you were a little concerned about how you would solve that. Let's not get too. Say again.
4K.
Yeah, let's not get too worried about that because R of T, to find the antiderivative of R of T would truly be difficult. AKA probably not worth our time. And so I wouldn't worry too much about that because they did say, write but don't try to solve.
Yeah.
an equation. So from that perspective, let's not worry about it too much. What do you guys think about the substance of it? Mark, what do you think?
Wouldn't it be plus in there because you get a negative number from the integral right there, and then you have to add it, and then once that equals 0, then
It was initially a positive rate. It just said that it was blowing out, and then we subtracted it in A of t. So I think that it should be negative.
I'm just listening right now, that's all. So Mark, hey, Mark, I want to be really clear about this. So you guys totally agree with Titus except for the plus versus minus.
yeah.
Come on, let me hold you in suspense for a little while longer. Does anybody have a third alternative? Yeah.
I don't have a third alternative, but can I argue for Titus?
You have an opinion on plus or minus. Okay, go ahead.
If it was positive, then A prime would be WT plus RT, but that's not what A prime is. It's minus RT. So RT should be negative in this equation.
I love it. We got a math throwdown here. Trash talk. So, hey guys, I appreciate the math intensity here. Let's continue to progress. Natalie, you had something you wanted to add?
Yeah, it might be wrong, but I put the 1300 inside the integral.
Oh, the 1310 inside?
Oh, yeah, sorry.
So, tell me exactly what we should write. Integral.
So integral from 18 to k of 1310 minus RT dt.
Okay. Okay. And I'm looking for all alternatives. And we'll narrow this down pretty quickly and say, here's what we would go with, here's what we wouldn't go with. Okay. But I want to hear alternatives like that, the plus minus alternative. Does anybody have something different that you're like, I actually kind of think this one maybe would be right, or I'm not sure? Feel free to share. Obviously, there's going to be one person or one group that's going to be like, yes, and the others are going to be like, I was so close, or whatever. It's okay to be wrong. It's totally okay to be wrong. You're in class. It's a safe place, I hope. So that's it. So does every single person fall into one of those three camps? Every single person is like, yep, I think it's one of those three things. Giving you a chance to disagree. Okay, so let's start with this. Natalie, it actually doesn't belong in there, and let me tell you why. The 1310 does not belong in there. We can look at this from a couple perspectives, but I would ask you, what kind of thing is R of t?
Rate.
It's a rate. What kind of thing is 1310?
An amount.
Yeah. So if we go amount minus rate, it's apples and oranges, right? We're not going to be able to compute something usable from that. So the 1310 really does need to be outside of the integrand, simply because, the integral, the definite integral of R of t is going to give you some sort of an amount, right? So once you take that 1310 out, you'll essentially be combining an amount with another amount. Okay, so I'll take that one away. But Natalie, what you just asked about with should the 1310 be in there is a very reasonable question. It's been asked and tried many, many times. It's worth saying. I'm glad you said that. Maybe there might have been some other folks thinking that. So now we come down to the plus and the minus. Which one is it?
Division.
Oh, Dan wants to add something to the mix. You agree with Titus now. Oh, a conversion. Team Titus just gained a member. Fair enough. Fair enough. So, I suppose that this could somewhat be settled by doing a test with war. Yeah, it's all out war. Yeah, that sounds great. No holds barred. No, this could be somewhat settled. I want to give you a way to figure this out for yourselves. K obviously needs to be some number bigger than 18, right?
Yes.
So if you took your calculator and you did math 9, and maybe you did it with 18 to 20 or 18 to 25 or something, and noticed what kind of number came out, you might be able to decide for yourselves conclusively that yes, it should be plus or minus, and make your choice. All right? So give it a shot. Those that want to, unless you're just so confident. Definite integral from 18 to something bigger than 18. If you get a positive number, that could mean one thing. If you get a negative number, that could mean something else.
I mean, I wasn't gonna use it.
So you got positive numbers, right?
Yes.
So it does need to be minus, simply because R of t is simply presented as a rate, and in order to combine them, the reasoning that you used, Jonathan, Christine, I don't know if you caught that. You're like, I didn't quite follow what Jonathan said. He actually used pretty good reasoning. He said, because earlier we said W of t minus R of t to get our net rate, the same kind of reasoning would have to hold true here. R of t is simply a rate, and it's presented as positive numbers. So to say, hey, it's actually removing water, you've got to subtract it. And so that would be the same kind of reasoning as this. Yeah.
Could you write it as like 1310 plus the integral of 18 to k of negative RT?
Yes. You could move that negative in there. You could. You definitely could. Okay. Can I show you one other way that you could have written this? This
Is this right?
This is right. This is well done. Hey guys, honestly, let me say this. So folks in Mark's group, some folks are like, yeah, I think it's a plus sign. Dan got converted somewhere in the middle there. Hey guys, listen. The fact that you were able to come up with that and just be off by a sign is very good, right? That tells me that you're starting to really get this. The fact that others were like, hey, I think it's actually a minus. Obviously, that's one little tiny bit closer. It's better because they're there. But just the fact that you're using the integral and you got the 18 to k and all that stuff, that you're making huge progress. That's really, really good. I'm very encouraged by that. Yeah, question?
So where does the fundamental, or the second fundamental theorem come in?
Not on this at all. Well, yeah, kind of, sort of, because R of t is a rate. So R of t would be sort of like something prime.
Okay.
And so the definite integral of something prime would just end up being something.
Okay.
So the second fundamental theorem essentially says that the derivative and the integral cancel each other out. Okay, I'm not going to. I was going to show you one other way to look at it, but I don't want to. I don't think I would confuse you, but I don't think it's going to add to your knowledge at this point. So we'll just leave it alone. And I want to have time to finish our last thing for the day. So we'll leave this alone if you're all good. Questions? No? Okay, I'm very, very happy with that. I think you're doing great. Number of eagles in a wildlife preserve is modeled by E of t, where t is time in days. Using correct units, so this is another one of those sentence responses. You're going to use a sentence or two maybe. Using correct units, explain the meaning of the integral from 0 to 31 of e prime of t dt. And we did one the other day with the Paul's TVs or whatever. This one's a little bit different. Take a few minutes, see if you can write out what you think this means. And really, Caroline, this is sort of getting at the question you just asked about fundamental theorem of calculus, part 1 and 2, and how does it all work together and that kind of thing. So see if that helps. I hope it does. Doug, Dan, either one of you guys have a thought on what this might mean?
I said it was the amount of change in eagles from 0 days to 31 days.
Amount of change of eagles from 0 to 31 days. Did I get that down correctly, Doug? Okay. And Dan just said, I agree with Doug. Okay. How do the rest of you guys feel?
I feel good about that.
Amount of change of eagles from 0 days to 31 days. Yes.
I just have a question about like this type of question.
Yes.
Would you want us to define what e prime of t is also?
No, because we're more looking for like the overall meaning. Like if you were to like do whatever this was and got an answer for it, what would be the meaning of the answer? Yeah. Of course, e prime is the rate, right? Rate of change. Okay. So there's no disagreement whatsoever with Doug. You basically have more or less word for word what Doug wrote. If that's true. That's good because I think Doug is good. The only thing that you could add, and I think this would be overkill for sure. But if you said measured in the number of eagles, measured in eagles or something like that, and that's overkill because you said amount of eagles. So that's kind of an explanation and a unit, more or less. So I mean that would be overkill. But if somebody, I just wanted to let you know if you put that, maybe a little redundant, but it's okay. I think it would be fine. Doug, great job. Awesome. Can I ask you guys to do one more little thing with this? If we had integral from 0 to 31 of e prime of t, if I asked you to simplify that symbolically, what would the right side of the equation look like?
E of t.
That's what I'm looking for. It would be e of 31 minus e of 0. And you're right. The kind of an in-between step would be e of t, evaluated from, 0 to 31. I would like it if you could go straight there, like what Macy just said. I think that would be helpful for you. And can you see how Doug's explanation is illustrated right there? This over here on the right side, that is the amount of change of eagles from day 0 to 31, right? You're saying the number of eagles at day 31 minus the number of eagles at day 0, that's the change in the amount of eagles. Okay, this is starting to come together. I'm seeing it come together. I hope that you feel the same way. We got one more to do. Let's flip backwards one problem. This, unless I'm missing something, I think this is it for AP question, but it is very similar to one that was even asked last year and other years as well. So what you've got here is a piecewise linear graph, and this piecewise linear graph is a graph of f prime. I've labeled that in a couple different spots. And then the question on the left there says, find the absolute extrema, so that would be the absolute min and the absolute max, find both, of f of x, given the graph of f prime and the fact that f of negative 2 is equal to 3. I'm going to help you get started on this by asking you a few questions. I'm going to have you try to do the bulk of this on your own once you kind of get the idea behind it. But let me ask you one big question. I've mostly given you information about what? F prime. But mostly, I gave you a little bit of a clue about f, right? I said f of negative 2 equals 3. But most of the information I gave you had to do with f prime. And now I'm asking you questions about f. So what are you going to have to do in there somewhere? You're going to have to do an integral, right? To go from information about f prime to get to f, you're going to have to integrate somewhere, somehow, to get there. So with that in mind, let's take a step back. What did I ask you for again? When you hear those words, what comes to mind? Endpoints and critical numbers. Yes. So candidates. So what I'm going to do is I'm just going to come over here and I'm going to make my table right now with all my candidates. And let's go in numerical order. What would be the lowest candidate? Negative 7. That's an endpoint, of course. And of course, the other endpoint is when x is 8. But let's catch all the ones in between. What would be the lowest valued critical number? Negative 6. How do you know that negative 6 is a critical number? It?
F prime.
F prime. And specifically is 0, right, at negative 6. So negative 6 is a critical number. What's the next critical number up from there? Negative 2. And then one more critical number. And then lastly, got that endpoint of 8. So those are all of my candidates. We need to analyze all of those to be able to answer this question. What would the right column be? It would be f of x, yep, or a y value. But it would not be y prime or f prime. It would just be the y value. Okay. Of all those candidates, Mark, bad choice, right? Yeah. Of all those candidates, we already know about one of them. Which one do we know about? Yeah, we know that f of negative 2 is 3. But all the rest of them, we don't know anything about them yet. Okay, so let's go from left to right. Let's tackle negative 7 as a candidate first. And you all said it earlier, and you were right. If I'm going to go from f prime to f, I'm going to have to do an integral. My question to you is, integral, cool. What limits? If I'm targeting negative 7, what limits should I put on the integral? Negative 7 and negative 2. I agree. So I'll come over here and do a little bit of work. Integral from negatives. Yeah, we're going to talk about y. We know f of negative 2, and we're looking for f of negative 7. So whenever you set up a definite integral like this, you want one of the limits to be something that you do know, and the other one would be something that you want to know. So that's a good idea for sure. It's going to be the definite integral of f prime of x. This is what we talked about with that eagle problem just a second ago. What would the right side of this look like?
Negative 2 minus f of negative 7.
Yep. F of negative 2 minus f of negative 7. Notice that the primes are gone. The prime is gone because the integral and the derivative undo each other, and using FTC 1 and 2, you get the difference between the upper and lower limits. We can actually solve this. Check this out. So on the right, we know that f of negative 2 is 3. We want to know f of negative 7. You can see how good your memories are. How on earth am I supposed to figure out the definite integral from negative 7 to negative 2?
You flip it.
Not flip it. Area. If you can't integrate, accumulate. Nice memory. Good job. So if you can't integrate, accumulate, and what we're accumulating is area. Can I explain something that I have seen as an AP reader that I would just so much encourage you to not do?
Yeah.
Okay. I've seen problems like this in the past. I saw this last year where it's piecewise linear. And isn't it very possible to find the equation of a line if you know 2 points? So I've seen people look at something like this and say, well, I know I need to integrate, right? And so they find the equation of that line. Y equals something or other x plus whatever. And then they find the equation of this line. And then they find the equation of that line. And they do all these little integrals. And you can totally do it. And it totally works. And some folks took up massive amounts of space on their test. And they got it right. Others that did it just totally blew it up and messed it up. But it's so much easier just to say, if you can't integrate, accumulate area. Because what are all the shapes up there? They're all just triangles, and if you can find the area of a triangle, you don't have to go through all the pain of trying to figure out those linear equations and setting up all these integrals with these linear equations. So please don't do that. Please just use area to figure out the integral. So let's do that. Let's try. This right here, oops. There's one little triangle right there. What's the area of that particular triangle?
1.5.
It's 1 by 3, isn't it? Yeah, so 1.5. That makes sense? So that would get us from negative 7 to negative 6. So we've got to go a little bit further. We've got to come up with the area of this triangle. Let's see here. So it would be a base length of 4, right? And a height of 4. So does 8 make sense to you guys as well? Okay. So this has an area of 8. And that would get us to negative 2, wouldn't it? Okay, so as I accumulate from left to right, what's going to happen with that 1.5? It's going to be negative because all of that area is below the x-axis. And so I would replace this integral with negative 1.5 plus positive 8. You see how I'm just accumulating the area from left to right? You can choose to do it that way, which I happen to think is easier just because you do the area of a triangle carefully, please, because it's easy to mess that up. And you're good. We'll reuse that again here in just a second, versus trying to figure out what the equation of those lines would be. That's a mess, let me just tell you. Okay, so let's figure out what f of negative 7 is. Negative 1.5 plus 8 is 6.5, and that's equal to 3 minus f of negative 7. So I'm coming up with, what, negative 3.5? Negative 3.5 is equal to f of negative 7. So that goes right there. And just like it says sometimes on the shampoo bottle, rinse rather and repeat. We're going to repeat that process several more times to handle the other candidates. So if you guys would, take a few minutes here. We've got quite a bit of time left. I think we've got more than enough time for us to get all these. I'm going to leave it up to you guys for a few minutes here to try to come up with the y values for the other 3 candidates, and we'll be able to make our decision at the end of that. So if we're targeting negative 6, did you guys do the integral from negative 6 to negative 2 of f prime? So again, we're trying to set up that convention of one of the limits is something that we do know, and the other one is something that we want to know. So this would give you f of negative 2 minus f of negative 6. And for an area, we got 8, right? We had that from before. So I'd say we can replace this entire integral with 8, and f of negative 2 gets replaced with 3. And so we get f of negative 6. Did you guys get negative 5? Negative 5? Okay, so I think we put negative 5 right here. And I'm going to do a little erasing. And again, just for the sake of the video, we'll try to do the rest of this. What area did you guys get for that next triangle that's below the x-axis? Do you guys get 6? Okay, yeah, 6 is definitely correct. So you do 1/2 base times height, you get 6 there. It's pretty repetitive, but I hope that it's beneficial, especially for those that need to watch this. So this is an area of 6, and then how about the little triangle on the end? That one is way out of scale, isn't it?
It is.
Yeah, so 4 by 2, yep, so that's an area of 4. So for targeting 4, we would do the integral from -2 to 4 of f prime. This is pretty important here that we keep the lower limit, the lower number, and the higher limit, the higher number, because we want to accumulate from left to right, not right to left, just to be consistent at least. So we'd say that this is equal to f of 4 minus f of -2. The integral from -2 to 4 can be replaced by -6. And let's see here, f of -2 is 3, so I'm getting -3. You all get the same thing? Okay. And then finally, for the last one, integral from -2 to 8, to get our final value, this would equal f of 8 minus 3. What'd you guys get for that integral? Just for the integral side. I think -2, right? -6 plus 4? So -2 equals f of 8 minus -3. Okay, and then you add 3 and you get 1? Okay, so the final thing you want to do then is call out your answers. And so we can see then, I'll just write it up here, that the max is what? -2, 3, so that's the point. Highest y value is 3. Oops, did I want to do that? I don't know what just happened. There we go. The max is just did it again. We'll do that. Yes, I have a theme song and everything. There we go. Soundtrack included. All right, so the minimum then would be what? -6, -5. And we've called out our answers. And we're good. So you look very calm. That's a good sign, right? You look calm, confident. Yes? Okay. Are there any follow-up questions of any kind? Not cheesy, fake grin. Just calm and confident. Okay. All right. That's good. That's good. Okay. So we'll leave this alone if you're good. I would like to maybe throw one review question at you. One that I know that I threw at you earlier this week, and I kind of got the blank stare. So can I throw one review at you real quick? Okay. So this would be a handy thing for you.